Okay, in this video, we're going to use the concepts of turning points, critical points, to solve a trajectory type problem. And here's how it's set up. A particle is projected upward and has an initial velocity of p feet per second. And the formula for finding the height of the particle, that's this. It will equal p times t minus 16t squared, where t, that's the time of the flight. The time is measured in seconds, the distance is measured in feet, and our velocity is measured in feet per second. So the height of the particle at any time depends upon what our initial velocity is. And we're asked this: if we want to have a maximum height for the particle of 49 feet, what does the initial velocity have to be? So, let's see, before we try and figure this out, let's just draw a quick and crude diagram here. This is height, and this axis is time. So our trajectory is just going to look something like this. And we know what the equation of this curve is. It's h equals our initial velocity multiplied by the time minus 16 times t squared. And when it reaches that maximum height, right there, the slope of that curve is 0. And the slope, of course, is the change in h with respect to t, and we know how to find that. That's just going to be equal to p minus 32 times t. Now, h, that's our height, so this is distance. So we're taking the derivative here of distance with respect to time. So this right here, that's the instantaneous velocity of our particle throughout the flight. That's the initial velocity of the particle. Of course, that's time in seconds. And when it reaches this turning point right here, and that is equal to 0. Or that is saying then that p equals 32 times t. Now what is t? T is this value of t right here. Whatever time it takes to reach that maximum height, that time multiplied by 32 is equal to the initial velocity. And we know what this is. That's 49 feet. Let's go back and use our formula here. 49 is going to equal p. Well, that's this. 32t times t. 32 times t squared minus 16 times t squared. So that's the 16t squared. So the time squared that it takes to reach that maximum height that's 49 divided by 16, and t equals 7 over 4 seconds. So that's what this value of t is. It's 1 3/4 seconds. And that's how long it takes to reach that maximum height of 49 feet. And as you can see, by using that concept of critical points and turning points and how to find the derivative of the curve, we could find this out pretty quickly. And then once we know this, we can go right back to here and determine what our initial velocity has to be. That's going to be 32 times 7 over 4. So that will equal 56 feet per second. And that's it. That's the end of the problem. So as you can see, it's not a difficult problem. Hopefully you found an interesting application. And also hopefully at this point you're getting an appreciation for these techniques now that you're learning in your calculus course. There's all kinds of interesting problems that you can solve with these techniques. They're pretty powerful, really. So come back and join us for some more videos, and we'll see if we can solve some more problems.